Hi, I'm Kyle with DIY Auto Homeschool, and it's kind of warm here today. We're looking at a 2002 Honda Passport for a ABS light that stays on the whole time while driving. So first thing we're going to do is get the scan tool, hook up to it, and see if we can pull the codes. On the driver's side of the vehicle, this is where the driver's door would shut at. Right up here is the plug-in for your scan tool, the DLC. So we'll just, if I can, plug that in. And on this one, you can see the green light. That just means it's got power, ground, it's plugged in. So let's go to the scan tool and see what we can find. Okay, so we've got the scan tool hooked up, plugged in. Turn the key to the on position. And we're going to go to, we don't want the global OBD2, we want to go through the scan tool function, the manufacturer specific function. And we are looking at a Honda. We'll try the automatic ID, although I suspect with the vehicle it might not do too well with the auto ID. We'll find out. Okay, so it says vehicle does not support automatic ID. Select exit to manually ID vehicle. I probably edited out the long wait, so it wasn't as long for you as it was for me. So we'll click exit, and this is an 02, and it is a Passport. It's a one engine option, and okay. And what we are interested in is the anti-lock brake system. Manual codes only. Well, oh well, that's what we got to work with. How to get codes? To gather ABS codes, jumper OBD2 connector pins 4 and 12 ABS lamp flashes codes, and it looks like they give us a list of what all the codes stand for. So looks like we're getting flash codes. We're going to go ahead and leave this list up so that when we get it, we can reference back to this to see what the code that we get or codes that we get mean. So let's just leave that where it is, and we'll go look at the connector, and I'll show you how we're going to jump this together. Alright. What they're talking about, this is the OBD2 connector, or the DLC, data link connector. It's where we plug the scan tool in. Now what it's telling us is that to get these codes, we're going to take this and unplug it, and we'll get a look at the face of this down here, and we want to jumper pins 4 and 12 together, and I'll show you the numbering and how we're going to jump it. But I'm going to have to take the camera off the tripod and try to get it propped up down there to get any kind of a decent view of this. So let's get that set up and we'll get going. Okay, so this is the DLC, and when you look at this, it's kind of hard for me because I can't get a straight look at it when I got the camera on it, but this pin right here, this plug right here is going to be number 1, and we will count, let me get repositioned here, we will count across here 1, 2, 3, 4, so that's one of the pins we're going to be jumping, 5, 6, 7, 8, and then 9, 10, 11, 12, 13, 14, 15, 16. This is a 16 pin connector. So it looks like 4 and 12 are going to be right across from each other. Let's count this. 1, 2, 3, 4 is going to be this one, and we know it goes to 8. So this will be 9, 10, 11, 12. Yeah, it looks like they're going to be right there. So we're going to take, I've just got a paper clip, and you want to be very careful when you do this. You don't want to shove this way down deep in there and spread the terminals open. All you need to do is just touch the terminals, and they should make the connection, and then we'll go look at the dash, look at the ABS light, and see how it flashes and pull codes from that. So I'm going to go ahead and stick this in here. Just enough to touch. And we're going to go look at the ABS light. Okay, so we've got that jumper in from pin 4 to 12. What we're going to do is we're going to turn the key on, and we're going to count the codes, and we're going to count the flashes, and that's going to give us the codes. Now the way this typically goes is there'll be a flash or a number of flashes, and that will be the first digit. There'll be a pause, and then there'll be more flashes, and that will be your second digit. And then there'll be a long pause, and they'll go to the next code or repeat that code sometimes. The most common setup is that we'll see a code 3 times, and then it'll move on to the next code. Now, what you may or may not have seen at the top of the list on that code list was code 12, which is 1, 2. I expect to see that code first and probably last, or the start of repeating the process again. So when we turn the key on here, we can expect to see code 12 and then whatever code we're looking at or codes we're looking at, and then probably end it off with code 12 again. So, but don't jump at the first code you see and think that's the only thing in there. Give it time to flash and see what you really got to work with. So let's go ahead and do this. 1, or that was on 1, 1, 2, 1, 1, 2, 1, 1, 2, 6, 3, 6, 3, 6, 3, 5, 3, 5, 3, 5, 3, 6, 3, 6, 3, 6, 3, 1, 3, or 2, 1, 2, 1, and 2. Okay, it looks like it's starting over. We got back to okay. All right, so let's talk about those codes real quick. Okay, sorry I don't have the usual lighting setup I usually have when we're over here at the board, but I just want to touch real quick. I want to kind of write out what we found when we got that light. We got a 12, then 12, then 12, then 6, 3, 6, 3, 6, 3, 5, 3, 5, 3, 5, 3, and then we got 6, 3, 6, 3, 6, 3, and 1, 2, 1, 2, 1, 2. Okay, so this 1, 2, 1, 2, 1, 2 is almost certainly it just starting over or signifying the end. The description on that list, and I'll show you when we get back on the scan tool, was system test running, a system okay. So it's just telling us that it's running its test and that everything's okay. It's looking for faults and it's going to tell us what's going on. Now, 63, as you'll see when we get back on that list, is a short in the rear speed sensor signal, and 53 is an open. Now, the reason we've got 63, 53, 63 is it's probably these are probably current, and this is probably history, or vice versa. I'm not 100% certain. It could be either way, but it's not super important that we know if this is history or this is current. What we know is that between the history and current codes, we are seeing a short and we are seeing an open. And I'm going to show you one more thing on the scan tool that can be really helpful for those of you that have them before we jump under the vehicle and actually put a meter on this sensor and see what's going on with it. So let's jump back on the scan tool and do that. Okay, before we go down and check that, which we still are going to need to, there's another function here that I wanted to point out for those of you that have Veris or Snap-on products. The Troubleshooter, often overlooked, can be very helpful. Let's see what we find here. ABS system, read first. Introduction, read first. Okay, let's read this first. Vehicle has been identified as a 2002 Passport with a 3.2 liter engine. Write down the following info and re-ID as an Isuzu Rodeo. Field techs recommend that the most current primary software be used with this content due to continual feature and model performance updates. Which is actually a little surprising, but not surprising that they're asking us to re-ID as an Isuzu Rodeo, because that's what this vehicle is. It's an Isuzu Rodeo that I guess Honda decided they wanted to sell and call it a Passport. So I'm going to re-ID it as an Isuzu Rodeo. We're just going to click, let's see, switch vehicle. Oh, okay. It's going to make me stop communication. You'd think I'd know that by now. Okay. We're going to call this an Isuzu, a 2002. Before we go farther, let's make sure the key's on. Key's on. And it is a Rodeo. Well, it's not a Rodeo, but we're going to call it a Rodeo. Rear-wheel drive with a 3.2 liter V6. Okay. Analog brakes. Manual codes only. Troubleshooter. ABS. Read first. Same information as before. Code tips. Now they got all sorts of helpful stuff for us, don't they? Let's click on our 53 or 63 rear wheel sensor. Codes 53 sets when the detects open or shorten rear for missing wheel speed signal. Okay, here's what I was hoping to find, and I'm glad I did. Check resistance at sensor connector. If resistance is within 1 kiloohm to 1.6 kiloohms, check for faults in harness between sensor and EHCU. If no fault found in harness, replace EHCU and recheck. Oh, okay, that's if the resistance is. So that's the resistance specification that we're looking for when we go down there. Like I said, the Troubleshooter on here is very helpful. So those of you who have the Troubleshooter, use it. Okay, sorry, another quick stop here at the board just to make sure everyone understands what we're doing going underneath this vehicle and what we're looking at here. So the two codes we've got are 53 and 63. And as it said there in that Troubleshooter, 63, which is described as a short, is actually set when there's no signal. So we want to get the idea that we're testing for a short out of our head and just think of this as a no signal code. And then 53 as an open. An open and no signal, because if you have an open circuit, you will end up with no signal. That's kind of how these sensors work. We won't dive into how these sensors work in this video. I will make, as we go and do the repair on this video, or the repair on this vehicle that we figure out in this video, I will talk more about how that sensor works. But now, like I said, don't think about a short. We're looking for no signal. And that's why it's very important to find the information that you can find with whatever resources you have, because we could have been just a little bit more confused looking for a short when it's actually a no signal code more than it is a short code. So we're looking for an open and no signal. I'm not going to jump to conclusions, but we're probably going to end up finding a bad sensor. That's usually the case, but you don't want to just make that assumption and jump at it. We're going to go down there and we're going to unplug the sensor, and we're going to back probe at the sensor, and we're going to check the resistance. And if we have between 1 kilo ohm and 1.6 kilo ohms, then we need to dive into the harness. If we find a open or an out of limits there, then we know we got a bad sensor and we need to put the sensor in it, and that's going to take care of our problem. Yes, there is a possibility that we could have damage in the harness, but the likelihood that you have damage in the harness and an open sensor, if that's what we find, highly unlikely. So we're going to check the sensor and we're going to see what we find, and we'll pick up there. Okay, sorry it's a little shaky, but up here on top of the differential that's the speed sensor where it goes in, and it comes up to where it plugs into the harness right there. Let's go to the other side and see if we can get a better look at this. Okay, there's that connection, and what we want to do here is we want to unplug this. This is the vehicle harness side, and we want to look at this real good, make sure there's no burned or messed up connections, and those look like they're pretty good. Make sure the wiring here, we don't see any major issues with it. And then this is where we're going to hook on to do our testing, and I'm going to try to reposition and get a better shot of that with better light. So let me try to do that. Okay, we've got the meter here set on resistance, and what I've got are these two wires that are actually female terminal ends, which I believe are what I'm going to need to hook into there. That way I can go in there and just slide onto the terminals without damaging anything or risking touching one lead to the other, and get an accurate measurement on resistance. So let's get this set up in there and see what we find. Okay, so those are both slid onto the leads in there that goes down to the sensor, and we've got one lead on there, one lead clipped on there. Let's see what our resistance is. It's out of limits. That's what those arrows mean, is that it's above the ability of the scale to measure it. And just to verify, make sure we don't have something going on with our leads, we can pull the leads down here. Let's set the camera over here, well, out of the way for just a second, because it's going to be hard to do this with it in my hand. Okay, you can see the scale is still out of limits, and we're going to take these two, we're going to clamp them together, and it drops our scale down 0.05. So that means our leads are working. We register that we have continuity, then we register that it goes out of limits. That sensor is an open circuit, so this vehicle is going to need a sensor. Let's get out from under the vehicle and we'll wrap up. Okay, well, turned out not to be too bad. It's going to need a sensor. I'm not going to go ahead and do that today in this video. This video will be about the diagnosis of it, and here in the next week sometime, this is a vehicle I drive, so it's not a huge hurry for me. Here in the next week sometime, I'll get a sensor for it, and I'll get that put in, and I'll make a video on putting that sensor in. So now you know how to pull the codes, a little bit of a process to go through, and this should reiterate, if nothing else, to those of you that have the Snap-on products. Use your Troubleshooter. You can find information in there without having to go through service information, look it up. It was real easy to find the ohm specifications right there. Now, we ended up having a completely open circuit in the sensor anyway, so we would have been able to determine that without the specification. But if we had not had a completely open circuit, if we'd had 10,000 ohms or 4,000 ohms, it would have been really nice to have that specification there. So thank you for watching the video. Thank you for being a part of what we're doing here on the channel, and I will see you guys in the next video.